right, so for our unit on sinusoidal functions, I can see celebration over there, so I know you just passed. For our unit on sinusoidal functions, we're ready to start word problems, so that's what we're going to do today. Remember that a sine or cosine function can be modeled with anything that has a pattern of repeating behavior, right? So for example, if you are bouncing a ball repeatedly at the same height, or if there's a wheel that's turning, or a Ferris wheel, or here are a couple of other examples, a turbine, a pendulum, something called an oscilloscope. So anything that has a repeating behavior can be drawn as a sine or cosine graph, and then you can analyze it. So today we're going to be talking a lot about wheels turning. Let's look at question number 1. It says, Dwayne repaired a punctured tire with a radius of 25 centimeters on his car by inserting a plug in the hole. Oh my goodness, this is actually so funny that this said that, because actually I'll pause this so the recording doesn't. All right, story is done. Back to the question. So Dwayne repaired a punctured tire. The tire has a radius of 25 centimeters on his car by inserting a plug in the hole. A graph of the height of the plug above the ground as the car is being driven is shown. So basically, if you visualize, there's a plug right at the top, and then the car is moving. So the plug is at the top, and then it goes to the bottom, and then it goes back to the top, and then it's just repeating this pattern over and over again. On the graph, we have distance above, the plug is above the ground, and then the distance that's traveled. And there are a couple of features that you can have on a wheel that are related to a graph. And this is the most important part. So the amplitude on a graph is the radius of the wheel, which makes sense, right? Because technically, if this is like the equation of axis, then this is the amplitude, and this would be the amplitude. From the maximum to the minimum, you can calculate the diameter of the wheel. The equation of axis is the axle of the wheel, which is just like right in the middle. And then one period is one rotation of the wheel, which is also the circumference of the wheel. So when the plug goes from top to bottom and all the way at the top, you've traveled one circumference and also a period. So given this information, let's answer a whole bunch of questions. Question number 1 says, where was the plug where the car began to travel? So we're going to look at the initial point right here. Where was the plug? We can say it was at the top of the wheel. And we can also give a numerical answer, which is top of the wheel, 50 centimeters above the ground. Question B, what is the period of this function and what does it represent in this situation? So we learned last class that when you have a graph, you can figure out the period just by looking at the start of the cycle to the end of the cycle. I do have to apologize. I feel like the numbers here are like super awkward, but what do you think is one period of this graph? Yeah, approximately 157.08. So we would say this is 157.08 centimeters. And what does the period represent on this graph? Yeah, one turn of the wheel, we could say. It can also represent how far you've traveled horizontally, right? Because if the wheel has traveled 157 centimeters, that means your car has also traveled that much. So we can also say it's the horizontal distance. And that makes sense because that's literally what the x-axis is. Determine the amplitude. What does it represent in this situation? So in order for us to determine the amplitude, first we have to figure out what is the equation, sorry, the axis, what am I trying to say? Equation of axis. The minimum is 0, the maximum is 50. That means where's the midpoint here? 25. So we can actually go ahead and draw a dashed line at 25 centimeters. And then from 25 centimeters to the top or the bottom, how much have you traveled? Just 25 centimeters. So if you really wanted to show the work for the amplitude, remember amplitude is attitude, so it would be 50, take away 0, divided by 2, and so that would be 25. And what does the amplitude represent? And in the actual wheel, it's the radius of the wheel. Yeah. All right, question D. How far has the car traveled when the plug touches the ground for the first time? So remember, the plug starts at the top, and then how far do you think it's gone when it touches the bottom of the ground? Radius of the wheel, and I just did the calculation for amplitude. 50 take away 0 divided by 2, which is 25. But really, you could just use logic for that and figure it out that way. Okay, so the plug starts at the top, and then how much has it traveled to reach the bottom? What's the calculation for that? So like this point right here. Oh, whoa, what was that? You would just take the period and divide it by 2, right? Because it takes half the distance to go to the bottom and then the other half of the distance to go back to the top. So the calculation for this would just be 157.08 divided by 2, which would give us a decimal. Um, 78.54. And then finally, question E, how far has the car traveled when the plug touches the ground for the 10th time? I would say this is a thinking question because you really have to think about what exactly is happening. Okay, so I'll give you a second to think about it. I'll do attendance and see if you can get the right answer. Yep, you're absolutely right. So there are actually two different ways you can think about this. We know the plug started at the top and then it went to the bottom. And then from there, you want to know when was the 10th time it reached the bottom. So you can think of it as 10 full rotations of the wheel, but then you have to subtract half a rotation. Because if you do 10 full rotations, the plug actually reaches back at the top. So you have to make sure to get the 10th time it touches the ground, you have to subtract half a rotation. Or you can think of it as 9 full rotations, and then you add half a rotation. So let's say I did the first way. One full rotation is 157. So I'd go 157.08 times 10 minus half a rotation is what we calculated in question D. So it'd be 78.54. And then we would get 1,492.26 centimeters as our answer. Like I said, this is a thinking question because it's not like so straightforward. You can't just multiply either one of those by 10 or 9. You have to add on to it. How do you guys feel about these types? Are they okay? We have 2 more examples to do, so I'm just going to keep going. Question number 2. At an amusement park, I'm very conceited in this question. I used my name. At an amusement park, I have different students riding 2 different Ferris wheels. Haya rode Ferris wheel A and Yusuf rode Ferris wheel B. I collected data and produced 2 graphs. So the first thing I want to do for these graphs is I want to identify key pieces of information before I even start to figure out what is happening and what the question is asking for. Okay, so first of all, I recognize the maximum value in the first graph is 12 and the minimum oh, sorry, it's not 12. It's actually, we need to add a couple of numbers. So this would be 13 here, and this would be 1. And then on this graph, this would be 7, and this would be 1. So we do need a little bit more information. The maximum here is 13, and the minimum here is 1. And for this graph, the maximum is 7, and the minimum is 1. And if you look at your axes, basically it's height over time. So how high is the Ferris wheel going as time progresses? So given this information, what do you think is the equation of axis for the first question? Remember, equation of axis, you add the maximum and the minimum. 13 plus 1 is 14, divided by 2 is 7. So that means at 7, we can make a dashed line. And I'm actually going to put in the number 7 here. And then for the other graph, we're going to go 7 plus 1 is 8. 8 divided by 2 is 4. So this equation of axis is going to be at 4. I haven't even started looking at the questions, but I always start with this just to give me an idea of like what exactly is happening in this question. Okay, so let's go ahead and answer questions for both of them. Let's start with what is the period for both of them? So remember, for the period, you just begin at a certain point and you end at a certain point. So I'm going to begin here and I'm going to end over here. And what do you get for the period for Ferris wheel A? Good. We'll do the same thing for the next one. So we start here and we end here and we get the same exact time, 40 seconds. What exactly does a period represent in this scenario of a Ferris wheel? What have we calculated 40 seconds to be? Aryan? Yeah, it's one full turn of the Ferris wheel. That means for both of these cases, it takes 40 seconds for a person to go around the Ferris wheel. So we'll just write one turn around the Ferris wheel. Another thing it represents is actually also a distance, right? It tells you the circumference of the Ferris wheel or the horizontal length of one cycle. But you know what? We won't complicate things. We'll just keep it as that. We've already determined the equation of axes. So for Ferris wheel A, it's y is equal to 7. If you wanted to show work for it, we just did 13 plus 1 divided by 2, which is equal to 7. And so therefore, y is equal to 7. And then for this one, it was, what was it? 7 plus 1 divided by 2, which is going to be 4. Therefore, y is equal to 4. In either one of these scenarios, what does the equation of axis actually represent? Is it the radius, the diameter, or something else? Not the radius, good try. It's the center of the Ferris wheel, the axle, which is like directly the middle of the Ferris wheel. Yes. So we're going to call this, or we're going to say this is the axle of Ferris wheel. Axle, or I'll call it the center. Okay, the next question says amplitude. So we can do the calculation for that, maximum minus minimum. So it's going to be 13 minus 1 divided by 2, which is going to be 12 divided by 2, and that's going to be 6. And for this one, it'll be 7 minus 1 divided by 2, which is going to be 3. I think you should always show calculations. I just think it makes it easier if you make a mistake, then I can give you part marks. What does the amplitude represent in this situation? What was that? Yep, how high it goes from the center, which is also known as the radius. Yes. So this is the radius of the Ferris wheel. All right, last question on the chart. What is the speed of the Ferris wheel? Now, this is something we haven't done before, but I think most of you are probably familiar with the equation for speed. Speed is just equal to distance over time. To figure out the distance of any circle, we're going to be looking at the circumference, which is 2 times pi times r divided by time. So once you know the radius, you can figure out the speed really easily just by putting it into the following calculation. So we'll show all of our work for it. V is equal to 2 times pi times the radius is 6 divided by, what are we going to put for time? 40, right? Because it takes 40 seconds to go one loop around, and one loop around is the circumference, which is 2 pi r. So we're going to divide that by 40. 2 times pi times 6 divided by 40. And I guess we'll just round it to two decimal places. It's going to be 0.94. And the units would just be meters per second, because our period was in seconds and the height is in meters. So meters per second. For the next question, again, speed is equal to 2 times pi times this radius is 3 divided by 40. And then we're going to notice the speed for this is 0.47 meters per second. By the way, take a look at this. Take a look at what's happening here. We have two Ferris wheels. They take the same amount of time to go one loop around, but Ferris wheel A has a radius of 6 meters, and Ferris wheel B has a radius of 3 meters. So you can kind of guess the radius of a Ferris wheel or any wheel is going to affect how fast you're going. What does this represent? It represents the speed. I don't know why I put an exclamation mark there. Okay, so let's answer the last couple of questions, because it's it has to do with what I was just talking about. How does changing the radius of the wheel affect the sinusoidal graph? So if you look at both of these graphs, you notice there's one radius here and there's one radius here. When you change the radius of a wheel on a graph, the amplitude is going to change. And then question B says, how does changing the height of the axle of the wheel affect the sinusoidal graph? So if you were to change the axle, like the midpoint of the Ferris wheel, what would change on a sinusoidal graph? What's that? The equation of axis. Good. So you change the radius of a wheel, the amplitude changes, and you change the height of the axle, then the equation of axis changes. Actually, we can say the equation of axis moves instead of changes. All right, last example. I was actually thinking that I would get you guys to do this on your own, and then I will put the solutions on. So go ahead and try this one. We still have about 10 minutes before we start our quiz, so try it and then check your answers with mine. So Zoha's shop teacher was discussing table saws. The teacher produced two different graphs for two different saws. In each case, the graphs show the height of one tooth on the circular blade relative to the cutting surface of the saw in terms of time. So here they are, you guys at home. I'll just show them to you. The graphs are time, and then it's height of cutting tooth in inches. So basically, like what it's saying is, this is your table. This is the part of the tooth that actually sticks out, like this part right there. And this is your table, and this is the part that sticks out. Okay, so to answer the questions, how high above the cutting surface is the blade set? So for the first one, it'd be 2 inches, and the second one would be 1 inch. Question number 2. What is the period of the function and what does it represent? So to figure out the period, we're just gonna find a point like this and here and figure out how much it goes. So the first one would be 0.02 and the second one would be, I would say, like in between 0.02 and 0.03. So 0.0225. Let's see, hold on. 2. This is 0.02. This is 0.04. Yeah, we can do our best guess. So I'm going to say this one, this would be 0.02 seconds. And then this would be, okay. Yeah, you can go ahead and check. Is it back there? Hold on, 0.0225 seconds. And what does it represent in this situation? Time for one rotation. doing? What is the amplitude of the function and what does it represent? So we're going to do maximum, which is 2, and minimum, which is -8, and we're going to subtract those. So it's going to be 2 minus -8 divided by 2, which is going to be 5 inches. And the amplitude in this one would be 1 and -11. So 1 minus -11 divided by 2, which is going to be 6 inches. And what does the amplitude represent? It's the radius of the saw. Okay, and the last question is, how fast is a tooth on the circular cutting blade traveling in inches per second? So for that, we need our formula. So I'm just going to use maybe this. So velocity is equal to distance over time. So v is equal to distance over time. But in this question, distance is 2 pi r over time. So we're going to go v is equal to 2 times pi, and the radius is just the amplitude times 5. And how long does it take? That's the your period. It's going to be 0.02. So 2 times pi times 5 divided by 0.02. That's going to give me 1,570.8. And our units are going to be, we just look at here, it's going to be inches over seconds. So it's going to be inches per second. We'll do the same thing for the other one. You know what? Why am I writing? I can just use the short form, which is just inches per second. And the next one is v is equal to 2 times pi times 6. And this period is 0.0225. So 2 times pi times 6 divided by 0.0225. And this is 1,675.5 inches per second. That's it. There's nothing on the next page. And then I'm just going to point out your homework, which is the bottom right-hand side of the page.